Kia ora koutou. This is the first of the differentiation excellence questions that I'm going to YouTube this year, and another great meme again, thanks to NCEA Memes on Instagram. This question I think is straightforward if you are confident with your trig identities. It looks disgusting, but it's actually one of those ones where it basically tells you what you have to work out. So you don't have to think very hard, you just have to get on with the differentiation. Right, so we're told that the radius of curvature of a function is a measure of how much the curve is bending at a given point, and we're going to be working with this curve here, y is equal to cos squared of 2x. And we want to find the radius of curvature at a specific point on that curve, which is when x is equal to pi on 3. So we're given the formula for the radius of curvature here, and you'll see that it's got the first derivative in it and the second derivative. So we need to get on with it and work out those two things. Okay, let's just try and move down the page. There we go. Right. Okay, so we've got some chain rule stuff going on. We've got y is equal to cos squared of 2x. I'm going to get on with doing this without doing an explicit substitution for u and v, because we have at this stage in the year been doing the chain rule over and over and over. If you've just started on chain rule problems and you've found this video, you need to go back and do lots of chain rule work to make this feel easy. So we're going to bring down the power. We get 2 cosine of 2x. We're going to times by the derivative of the inner function. So we're going to times it by 2, and we're going to times it by the derivative of the in the middle function, which is negative sine of 2x. And when we clean all of that up, we get negative 4 cos of 2x sine of 2x. But when we look at this, hopefully you spot straight away that we've got a double angle sine thing going on here. So it's actually better to leave it as negative 2 times 2 cos of 2x sine of 2x. And all of this is equal to negative 2 times sine of 2 lots of this, so sine of 4x. Right, so dy by dx is a very simple function, which means that finding the second derivative is really an achieved level skill. So the second derivative will be negative 2 times 4 cos of 4x, right? The 4 is from the inside function here, and the cosine is what we would get when we differentiate sine. So that gives me negative 8 cos of 4x. Now to put it into that big function, we're going to be working with those derivatives at a specific point, which is x is equal to pi on 3. And in both of these, we need to find, so for the first derivative, we need to be using 4 pi on 3, and for the second derivative, we're going to be using 4 pi on 3. I can't remember if it said exact values or not, but I'm assuming it did. Okay. Right. Oh, sorry about this, guys. Let me just fix up the stupid OneNote thing. Get rid of those. Okay, in the time I've been doing this, hopefully you've been sitting there and you have drawn your dinky little trig quadrant graph. So 4 pi on 3 means that I'm around here in this quadrant. So this is 4 pi on 3 here. I'm working with a special triangle, and we know that in this quadrant, both sine and cosine are going to be negative. Right, so sine of 4 pi on 3 is going to be negative root 3 on 2, and cosine of 4 pi on 3 will be, let's have a think, cosine of 4 pi on 3 will be negative 1/2, right? So that's using my special triangle. So I'm just going to do that really quickly in case you're sort of half confident with it. That length there is 1, that length is root 3, and this length is 2. And it's possibly the messiest graph I've ever drawn in a video. So maths teachers, if you're watching, I'm really sorry. Go do a better video. I'm sure it will have nicer graphs. Anyway, we haven't found the derivatives yet. We've just found the trig part. So we're going to take these and we're going to substitute them back into here. That gives me, for dy by dx, we want negative 2 sine 4x. So dy by dx at x is equal to pi on 3 is going to equal negative 2 times negative root 3 on 2, which is a nice clean root 3. And for the second derivative, d squared y by dx squared, when x is equal to pi on 3, we want negative 8 times negative 1/2, which gives me 4. So finally, we're ready to chuck all of that into the formula. So let's just go back up and see what it was. Oop, it's gone very small. Here it is. So we're going to do some substitution, and a whole lot of stuff is going to fall out. So P is equal to 1 plus root 3 squared to the power of 3 over 2. You do not need to grab your calculator, guys, right? Just do not grab the calculator. This is quite lovely. We get 1 plus 3 to the power of 3 over 2 over 4. And 4 square rooted gives me 2. 2 cubed is 8. So it's 8 over 4, which gives me a final answer of 2. So there you go. I think that's quite a straightforward excellence question. The formula looks terrible, but it's yet another example in the same 3-hour exam of just how important fluency is with trig, derivatives and integration. So that's really been hammered in this year's papers, which I think is a good thing. So again, make sure you do tons and tons of practice at that. If you're watching this in 2026 and you think you kind of know how to do chain rule things with trig, then it's not going to be enough to get you comfortably through the merit and excellence questions. Okay, so go find a whole lot more examples in all the places that you can find them and just do heaps and heaps of practice on those skills. Thanks for watching. I'll do a couple more tomorrow.